Hi, this is Jon Bek, and in this video segment, I'm going to complete a series of exercises that closely parallel your week 6 exercises, and hopefully you can use those to assist you in completing your actual week 6 work. All right, so I'm going to work in the zips collection once again. You'll be doing your actual work that this parallels back in the restaurants database, the primer dataset.json file that you've loaded. And let's just look at our zips database to refresh our memory of what it looks like. So we have the native key they've used for the actual zip code. It's a string because zip codes sometimes have leading zeros. Okay, it's problematic with a numeric type, so they made that decision. City location is an array of GIS coordinates, longitude, latitude, the population, the state in which that zip code is found, and just to refresh your memory about the way that zip codes work in any one state, the town, the city name, can only be associated. If you're familiar with Southern California, if you wonder why Mammoth Lakes is called Mammoth Lakes and not just Mammoth, and that's because there actually was at the time another zip code associated city that went by the name of Mammoth. So city council had to get together and call it Mammoth Lakes. However, we are not guaranteed to have uniqueness of city name across state boundaries. Only within the individual states. The zip codes, of course, are unique throughout the entire system in the U.S. Okay, so just a refresher on the way the data is laid out there. And this is a fairly simple database. There's just the one array value, and there are no, properly speaking, sub-documents or embedded documents. So that shouldn't be much of a complicating factor for us at this point. You should be all pros when handling sub-documents, which really aren't that big of a problem to deal with anyway. All right, so here is our parallel problem collection, and you can compare this with the wording of your actual problem statement, and you'll see that these are very similar, just working on this data set. So what you see here, what you learn here, you should be able to apply to your primer data set. So what you see here and what you learn here doesn't have to stay in Vegas. You can take it with you. Okay. So the first one is compose and execute a query which will group zip codes by state and count the number of zip codes that occur in each state. Okay, so we're going to be working with an aggregate. So let's go ahead and work on DB zips, and we'll bring up the aggregate phase. Helps to spell it correctly, of course. And I'll go ahead and open that with a left paren and begin block. And I'll just come down, make some space, and go ahead and close out those blocks while I'm thinking of it. And that kind of helps keep me get everything balanced. Okay, and then we're going to have a block here, and this block is going to house our group phase. And the group phase that we want to address is going to say that we're going to make the key for this group the underscore ID operator is going to group on state. And so we precede that with a $sign to say that's an expression referring to an attribute in the collection on which I'm working. The attribute or the field is named state. And we would like to perform a count on that, and that's really just a label there. The magic that makes the count happen is I say give it the sum and are my parentheses balanced? Helps if I line them up. Equal balance, let's give it a shot. Nope, I missed something. So here I'm balanced with this, but that final group is not balanced. So probably the right way, John. And maybe we can balance our indents so that, much nicer. Now we can see that it's balanced. Only it's not. Gotta love it. I should stick to cut and paste. And let's see. Missed the colon after group. And I still have an error in my script because it should return results. Let me take a look here. Group, and then open ID, colon, states, and the next clause after the comma, we're going to count on $sum, and it helps to work on a collection that actually exists. There it is. So I guess there's some benefit to my foibles after all, because some of you will make some mistake like that. And so remember to look if it seems to be working, but there are no results. Are you actually working on fields and collections that exist? So did you match that? And I have a feeling that what we'll see is Mongo and the other editors, they go along, will get more sophisticated with their IntelliSense and help us, overcome our own foolishness. Still wrong. What else is spelled wrong? Okay. I'm going to resort to the cheat sheet and just go for my notes and paste it in. That should be balanced. There we go. Okay, so now we have the rundown of states. We have not ordered our output. We were not asked to do so, but we have all of our states with the count of zip codes in that state. Okay, so very good. All right, let's take a look at our next problem. Revise your query from exercise number 1 and add a filter so that only zip codes in the state of California are in the results. Okay, so what we can do is everything you've learned in SQL is kind of whittling things away. We add clauses to make it more and more restrictive. What we do is we kind of build things up in Mongo. And so what we're going to do is we're going to add an additional match criteria that will filter it for us. And let's add the match phase in our aggregation right here. And what we would like to do on that one is, let's balance that while I'm thinking about it. We'd like to come in here and say the state attribute is equal to capital CA. Remember that case matters in Mongo. And now we've gotten that filtered down. So it was the same set. We filtered it to a subset of only those that match California. And there are 1,523 of them. Lovely. Okay. Let's take a look at parallel exercise number 3. In this exercise, we want to compose and execute an aggregate query, which is filtered display only the count of zip codes whose city is Anaheim. So remember, Anaheim's a fairly good-sized city. It will have many zip codes in it, and so we just want to look at the count of those that are in Anaheim. Okay. So let's see, we can keep the aggregate statement. We can change our match here so that the city is going to be Anaheim. Again, careful spelling in case matter. And I believe that I've got that right. In this case, the group is not going to be by state, but by the city attribute. Let's make that lowercase. And the count clause is just fine, so let's give that a shot. And there we go. So there are 7 zip codes in Anaheim, at least insofar as our database is concerned. Very good. All right. So moving on to number 4, compose a query that returns the highest zip code in the city of Costa Mesa. Be sure to show only the highest numbered zip code in our result. Okay, so let's see what we're going to do. The match criteria is going to be revised so that it's going to be Costa Mesa. Okay, and we can run that again and see that that's going along nicely. And let's revise that just a little bit. The group ID city and the count. Now, instead of being how many are there, we want the maximum value there. So we're going to change this from the $sum operator to the $max operator. And we're going to change this expression from a Boolean true to $sign. And what is the name of our zip code field? Oh yeah, and for whatever reason, the designers of the zips database decided to use the native key, which is a little bit confusing, but not insurmountably so. And let's see here. Let's add one more comma there because we're going to be adding additional criteria shortly. I think that will work. And there we go. Okay, so the answer to the question of what is the highest zip code in Costa Mesa, it is 92627. Nicely done. Okay. All right, moving on with a little space here. So we're going to modify our query from the previous step so that it's going to get the lowest numbered zip code within the city of Fort Lauderdale, and be sure to show only the lowest numbered zip code in the result. Okay, so if we change this to Fort Lauderdale, and let's think about this for just a moment. This will work. Let's go ahead and show that it works, and then I'll show you why this should be refined a little bit. We probably should have done the same thing for Costa Mesa. But let's go ahead and just do it this way. So ID city count, that's all fine. We want to change max to min. And let's run that. And so Fort Lauderdale, the lowest numbered zip in that city is 33301. Well, let's think about this just a moment. Is it possible that 2 cities across different states have the same name? They do, and I'm not certain, but I think that may mean that the zip codes could be the same. Maybe they make them unique. Maybe that's why Santa Clarita doesn't show up as, or Saugus doesn't show up as Saugus in Southern California, but rather shows under Agua Dulce when you look at the USPS codes. So maybe that's taken care of. But if we don't know, it would be safest to add an implicit and here and say, well, you know what, let's make sure that we're talking about the Fort Lauderdale that resides in Florida. And we can add that. If we do that correctly, nothing will change. So suddenly nothing is different. But now we're making sure that that's the Fort Lauderdale in Florida that we're getting and not the Fort Lauderdale in some other state, if that's relevant. So I guess the moral of the story is know your data, which in terms of USPS data, I don't. But failing that, code for safety. And so this gives us a little extra assuredness. All right, well enough there. Let's take a look at what comes next. So we got Fort Lauderdale. Number 6, compose a query that will display the city in Florida that has the highest average population across zip codes in that city. Holy smokes, this may take a little bit of thinking. So maybe we want to bring this in piece at a time because there's a lot going on there. So let's just kind of empty this out and let's leave the match criteria in and build it piece at a time. So the first thing we want to do is we want to find the city in the state of Florida that has some value in its projection. So let's just see about, okay, so that's working. We've matched Florida. So we filtered our database down to Florida. What next? Okay, well, we want to create a projection, and we want to sort. And then the other thing we're going to do after sorting it, we're using a sneaky trick here. We'd like to find the highest average population. And you would think intuitively, well, you're going to use, dollar max, get the maximum. That would make sense if this were SQL, but remember that the dollar max operator works at a document-centric level. So, gosh, does that mean we can't get the highest? Well, no, because if we were to sort the whole mess, which we know we can sort in the aggregation, we could take, if we sort descending, then the first one in the list, we just have this big ugly long list that has a bunch of stuff we don't want in it. But we can limit the results of our list. So we use a sneaky trick of sorting and then cutting off the head. So we only take the first result, and that gives us the highest. So there's your sneaky trick of the day. It allows us to emulate the max, but in the aggregation phase rather than in a single document. Okay, so how are we going to do that? So we're going to form a projection, and that's going to look like, let's go ahead and bring it in and I'll explain piecemeal. So there's our projection, and are we balanced? I think we are. So this is going to give us a projection. A projection is just a restructuring of our record so that it looks like the underlying data has the form that we want it to be formatted in. And so we're going to get city is true, and the population average is the average population. So we're making this projection is going to make it look like that's the data set we're working on, where it has cities and average population. And somewhere I am not balanced line 2, and line 1, line 2, unexpected token. The whole solution in. And cut something off. What have I cut off? Okay, there we go. So let's back up a little bit. Let's drop the sort and the limit out of this. Okay, so here's only the state of Florida with the projection gerrymandered to give us the city and the average population within each zip code of that city. Okay, so that's not the average population of the city at large. That's the average population across the individual zip codes. Okay, so a little bit different proposition, so be careful with what you're after, what you're defining. Don't confuse the two. And now we've got them in here, but the thing that we don't have is they are not sorted. We need to get the, what are we looking for, the most or the least? We're looking for the city that has the highest average per zip code. So we want to get them sorted -1. Okay, so this is going to sort it from least to most to least rather, most to least. So here's Hialeah, and there's Fort Lauderdale, and there's Jacksonville. And be careful, if you go do a wiki search or a Google search real quickly, you'll find that Hialeah is not the most populous city in Florida. It's not what we're saying. We're saying which city in Florida has the greatest average population per zip code. Okay, so kind of a density thing, a little bit different question. We'd use a very different query to answer the other question of total population per city. This is giving us the average population in each zip code on a city-by-city basis. And in this case, it's Hialeah. Now, that's our answer. We could take it and run with it. But if we want to really do this with some elegance, what we do is we make the query clean up the mess and give us only what we're looking for. So add limit 1, we get only the first record back, and now the query is complete and nice and neat. Nifty. Okay, and then question 7 in your actual assignment pertains to completing a walkthrough where you run a query, then you build an index, and you run the query again, and you run some database statistics to see how that query is performing and compare the two. And I'm not going to do that as a parallel exercise here because the entire walkthrough is really provided in the regular assignment exercise. And what I want you to do is compare that. What is the effect when you add an index to a database? Now remember, an index comes at a tremendous cost because every read and every write needs to update that index. And if you think about it, if it's not atomic, until that that update has completed, which you're going to have eventually consistent data, then you may be getting inconsistent results. So we need to think very carefully about whether we're very write-heavy or read-heavy on our database and how large the data is. In some cases, we may be better off in very large data running without an index. Certainly, there is a cost to reorganize and build indexes or rebuild indexes should the need arise. So we need to think very carefully about performance impacts. And on the upside, in the old SQL relational database model, you had data architects that worried about that, and you as a DBA or as an application developer were fairly well divorced from those kinds of concerns. The downside, if you work in a large corporate environment where you have a whole department of database analysts and data architects, is that as an application developer, you want to do something, you can be very, very frustrated because it can take months to get those folks, if ever, to agree to give you the indexes that you want in order to get the performance you need so that your application can run reasonably. And in some cases, they're not just stonewalling you, they are resistant because of the performance impacts. So the upside on a NoSQL environment is the application developer has a lot more flexibility to create what is needed as they go. So we have that whole idea of volume and velocity again. On the other hand, be careful. You're playing in a production environment, and of course you wouldn't be hopefully playing in a production environment. You're going to be playing in some sort of sandbox that's modeled and separate from your production environment. That always is kind of detrimental because the sandbox is never exactly the same. Usually it's not as large and doesn't have the same resources, and you can get led astray by performance analysis that's run on smaller data sets than live in production because things do not necessarily scale in a linear fashion, as you've seen if you've read the case studies and been paying attention this term, and certainly you've seen that in relational databases. So we still have some of the same performance elements having to do with scale and nonlinear drop-off in performance that might be expected. So that's it for this video. This is our last week of class. I wish everyone great success on the final exam. It's been a real pleasure sharing this adventure with you this term.